Time for another homework video, and you know the drill. The idea is that I show you an effect, like in this case, a couple of balls falling into a jar, and it's your job to figure out how to do something like that yourself with the knowledge we have so far. And only after you try to solve it, maybe in multiple ways, you should have a look at the solution I will show you in a second, and hopefully you will learn a thing or two doing that. So let's give it a try and see you after the break. Alright, so what we start with, of course, is a sphere that I already positioned above our jar, and the jar is pretty straightforward. You could come up with something a bit more complex. It starts with a tube, and this has closed caps, and thankfully SideFX decided to give the top primitive always the phase number 0, so we just blast this away. Then I put this on the ground, poly extrude this out. As usual, make sure that you don't forget to set the back to on, otherwise you will get into problems with the collisions. Then I do this again to get a bit of a harder edge, because I will subdivide the whole thing later on to soften it a little bit. But of course, that's completely up to you how to do that. Okay, first of all, of course, what we need is a vellum solver. That's straightforward. And now we have to bring in our sphere somehow. So first of all, let's connect our glass box with the collision geometry. That's the easy part. And then let's turn our spheres here into some kind of vellum object. The big question now is which one? And actually there is no definitive answer. You could even convert this just to a cloth and make it very stiff. But when we look at the result here again, the idea is that we get those little dents maybe on the edges of the glass. And this kind of implies that there is something that tries to keep the volume of our spheres. So we could choose from the pressure constraint, from the struts, or from the tetrahedrals. And you know what? Let's maybe try struts. Maybe you have a better idea, but I want to show you what would happen if we use the struts. So let's see what we get. Struts, vellum struts. We have the vellum struts by themselves, or the vellum configure strut soft body, which is actually the better choice because it will create everything we need. But let's do it from scratch and see what happens. Now, the first thing we would think about is, okay, maybe we just connect it to our simulation setup here. Let it run. But then we have the problem, we only get one sphere, and actually if we only look at the output, we can see what's happening to our sphere. It actually starts to completely go nuts. So what happened here? The first thing that we forgot is when you create struts, or when you use any kind of the three-dimensional vellum constraints, make sure that you first convert the outer layer as a cloth actually. So we need a combination of a vellum cloth and the vellum struts. And that's the cool thing about using the vellum configure strut soft body. It creates that for you to remind you. So we did this manually now, and let's see what happens now. There you go, and at least our sphere isn't exploding anymore. We can see there is a little bit of a dent here happening from our actual struts. Let's see if we can see them when we look maybe through here. They're literally struts between our points. But before we deal with how it deforms, why is there only one sphere? Well, of course, because we only put this in. But how can we make sure that we have multiple spheres constantly falling into our glass? Well, that's where we can actually go in and use the source output node in our dive target. And for this, there is the vellum source node. And this expects us to give us a path for the geometry and the constraints. Thankfully, we have this outside. And actually, the interesting thing now is we don't need a start geometry anymore necessarily. You could combine that, of course, with one. But in our case, all we want is we want to get the geometry and we want the constraints from our setup so that we can use them as a source for our vellum source here. So let's find that by searching for the out geo. So there it is. And we are lazy. We just copy the whole thing because I know the second one is called constraints. There you go. And the funny thing now is that actually it is possible that you use your vellum solver without an input here, interestingly enough. So let's see what happens. And now you can see we have multiple spheres falling down and they're even colliding. And actually that could be exactly what you need. It looks already pretty good with our struts. The one thing that we quickly want to solve here is we want to give them different colors. Now, one thing you can do here is just making sure that our source sphere gets a different color every single time. So let's use maybe an attribute adjust color, and let's set our color to random, which has the advantage that we can use this ramp here. Let's not put in green. I think that looks pretty ugly. But now we have the problem that, okay, now it gives random color to every single point here, as you can see. How do we solve this? Well, what we can do is, instead of using the element number, we use a custom attribute, for example, ID, which is nonsense because we don't have an ID, but this is actually a good solution that every single point gets the same color, and we just change the color with the seed. But if you would run this now, let's quickly do this, then we would still have the problem that every sphere is blue because we're not changing the color for every sphere. Now, what is different between those different spheres that we're creating here? Well, actually, the only difference really is in the beginning that the frame will be different. So what we do is we just put in here $F into our seed expression, which will make sure that every frame the ball will have a different color. And this way, when we run this, once the sphere is spawning, it will spawn with a different color. That's the whole idea. There you go. All right, so that's not too bad. Keep in mind, you can always change the behavior of this by changing either the outer membrane, by changing the stretch stiffness and the bend stiffness, or you can change how the internal struts behave. I don't want to go too deep into those settings, but by default it already looks kind of okay. The only thing here is, and that totally depends on your case, maybe depending on what our client wants, they might provide us with references, and here you can see, let's say this is a real reference, that we have those little wrinkles in our spheres. And those wrinkles actually suggest that maybe struts wouldn't be the right solution, because the struts will always try to keep the spheres as spheres. Whereas maybe another constraint like pressure would allow us to actually create wrinkles on the membrane. So let's actually change our struts. Maybe let's copy this for later. And let's change our struts to pressure. Now, of course, you could also create this from scratch with the Vellum Configure Balloon configuration. But what I noticed here by playing around is, if I just take this setup, the cloth is actually configured pretty well. So let's just change the struts to pressure, and then we can use the settings from the cloth, which are actually pretty good. And let's see how this looks like. And you can see they're a bit more bouncy, maybe a bit too bouncy. You can see there's not a lot of resistance coming from the pressure constraint. So let's increase that maybe to 10,000 or something. And let's have a look now. And of course, this is something where you have to experiment around with the right numbers. There's no way around it, unfortunately. But I think that looks pretty good. And the cool thing is we lowered the bend stiffness of our membrane. And this is actually a good trick here to get those folds. But again, this is just one possible solution to our case here. So let's sim this through. And as I said, you could also use tetrahedrals for this, or maybe you stay with struts. It really depends on what your final look is. And again, especially as a beginner, I would recommend just experimenting around with different numbers, different versions, different approaches to see where the fine details are different between those. So let's say we're happy with this. So let's cache this out. And of course, I use a file cache for this. And personally, I'm not a big fan of the constructed setup. So I actually will switch to explicit, and I already have here a preset saved where I set the hip name as my subfolder and then the name of the node itself. And let's call this balls. And let's say we sim out 300 frames of this. So let's have a look. There you go. So that's done. And let's bring this back in form of a file node before we render this. There you go, with an absolute path. There are our balls, great, with folds and everything. And now to finish this off, one last thing. Of course, if you decide maybe I don't like the colors anymore when I want to render this, sure, you potentially can go up here and change our attribute adjust color so that maybe, I don't know, the seed is +5 or something, or maybe you change the ramp or something. But that's kind of a pretty wasteful approach because you already have simmed the simulation. So the best thing is always to think about how can I change the stuff I need to change that is independent of the simulation without having to resim. And what should come to mind is to colorize different objects, we can use a connectivity node here to create a class attribute, and then we use, actually let's use an attribute adjust color again, and this time we just make sure we use random, sure, but then the attribute we use here is not ID, but of course class. There you go. And now I can actually change the colors of my spheres after the fact, and as you can see, that's even stable because the class will be created based on the already existing spheres. So this way you can, even after you cached out the whole thing, change the colors of your spheres. And like we saw before, once you render this, which we unfortunately can't go into in this video, if you quickly want to have a look at how I did this in Solaris, I bring in the balls and the glass separately, mainly because I want to have them in different hierarchies in my USD hierarchy. And then I use a material library to create two materials, glass and the spheres, and then assign them based on their hierarchy. So glass gets the glass material, balls get the balls material. And then I create a camera and an environment light from HDR Haven, the boiler room, by the way. And then when we render this in Karma, it looks something like this. And once it's rendered, it looks like this. So that was really quick, but the rendering, you know, is not what this course is about. You can, of course, do the same thing in Mantra as well. So yeah, I hope this is helpful, and take the time to experiment around with this setup yourself so that you find different solutions to this. Thanks very much and see you later. Cheers.